Hi, my name is Kyle Folsom, and today my data set is going to be used to determine the grade individual students will receive based on a variety of factors. The first concept I'd like to cover is the k-means within the clustering tool and how the distance between clusters will decrease as the number of clusters increases. Simply by changing the maximum number of clusters from 3 to 10, I can see both graphically and statistically how those cluster distances have decreased. So by simply looking at the two pie charts, by forcing more clusters to be created on the same data set, I am forcing the more specific clusters to be created, and thus the distance between clusters and the data within the clusters to its seed will be shorter than in the example of where there are only 3 clusters created. We can see this a little more statistically if we focus on the larger clusters in both examples. The distance to the nearest cluster where there are 10 clusters was 2.47, which is down from 3.32 in the 3 cluster example. Another metric we can look at is the maximum distance from the cluster seed, which in the 3 cluster example was 8.6, and in the 10 cluster this fell somewhere between 6.5 and 7. Now I'd like to move on to using predictive models to determine the letter grade each student will receive by using a neural network. The second concept I'd like to discuss is lift curves. Lift curves are used to determine whether a model is a better classifier than randomly classifying the sample. A model that creates a lift greater than 1 is said to be a better classifier than randomization, which we can see with this cumulative lift graph here. This neural network created a cumulative lift both in the training and validation data sets significantly greater than 1, showing that it is a better model than if I were to just randomly label grades to each individual student. Moving on to concept number 3, I want to evaluate my predictive model a little bit further by taking a look at true positive and true negative classifications. We can see over here that the neural network within the training data set correctly identified all true positive and all true negative data. Moving on to the validation data set, we have a slightly different result, some minor misclassifications. But of the 69 true positive, which is combining the number of true positives and false negatives, 62 out of the 69 were identified correctly. And then same thing for true negatives, 40 of the 49, combining true negative and false positive, were identified correctly. So neural networks are not the only predictive model I could use to identify grades among a population of students. Another tool that could be used is a decision tree. So how do I go about determining which model is the better method to use? Concept number 4 that I would like to discuss is the use of mean squared error in the model comparison tool as a way to evaluate which predictive model is the better fit for the set of data. So by looking at mean squared error, I can see within the training data set that the neural network has the lowest mean squared error, meaning it is the best fit for this data set. However, if I take a look at the validation data set, I can see the lowest mean squared error is with the decision tree. So as it stands right now, we cannot make a decision on which model is the better method to use. We would need to continue to test the two to determine this. However, one thing we can determine is that both the decision tree and neural network both have a mean squared error that is smaller than a random guess in both the training and validation sets. Thus, either of these models would be a better method to use than randomly classifying the grade of each student. Thanks. Have a great day.